Okay, all good.
Awesome. Okay, well, I'll just.
Oh, sorry, I caught you off guard, didn't I, Damien? With it.
It's all okay. I've just got too many windows open. Eventually, I'll find the right one and I'll share my screen. It's pretty bad. Get that over there. All right. Okay. All right. Sorry about that slow start, guys. Right. Welcome to Brisbane Azure User Group. Oh, pressing the wrong buttons already for March. So thanks everyone for turning up. Big thank you out there to our sponsors. So without Microsoft and Codify, this could not be possible. And we have a special guest from Codify tonight. So he's going to do our presentation. So welcome everyone. Without participation, and this is key to our group, it's not possible. So we're keenly looking for people to step up and get involved. It doesn't have to be a full presentation. Happy for people to have a conversation point, a topic they want to talk through, or a couple of short presentations by different people. That works too. So if you're keen to get involved, let us know. This is our schedule as we see it today. I'm hoping it's going to fill up pretty quickly, but that's up to you guys. So let us know, and we're keen to hear from you. There's our email down the bottom if you want to get in touch with the group. Flick that through. Awesome. So a few updates tonight before we get into the main event. There's a new region opening up in China. So for all those people who are working in China, that's now another option. A couple of updates just before we get into the main event, which hopefully is going to have a bit more insight than me, but there are insights that have come into the Azure portal for cost insights. So that looks pretty cool, and it can give you projections and all sorts of stuff around how you're spending your money. Defender for Cosmos DB has dropped into preview. So it's like all of the other Defender products. It's trying to protect the security, and it's monitoring things like SQL injection, suspicious patterns, identities, malicious insiders, and a lot of other things. And it's definitely worth checking out if you're using Cosmos. This one's interesting. So over the last couple of months, we've had a few announcements around the telco space in Azure. So Azure's really trying to bundle this together and give you the ability to spin up your own telco. So that's useful for organizations that want to have their own private telecom networks, private phones and all that sort of stuff, or public telecom providers who want to just provide telephones to everybody. Also, this one here, just out of the side, it looked interesting to me. Logs.io. So if you're using Elk and Prometheus and Jagger and those sort of things, this is a product that's in the marketplace that you can hook your all your insights from operation monitor and all that sort of stuff, and push them all through into this product to give you that user experience. Another thing, Spring Cloud Enterprise. So they just dropped a preview for this. So it's just a lot more capability and a lot more, SLA availability. So it lets you run your Spring Cloud workloads in an enterprise SKU. And then, so this one here is about Project Flash. So Project Flash, they're trying to get a lot better monitoring across all of the virtual machines and in Azure, and they're trying to bring out more statistics and information about availability of those virtual machines. So the first thing that they've dropped is a resource graph for you to be able to consume at scale virtual machines and their state. Okay, so a couple of resources. So we've got a Slack channel there, we've got a YouTube channel, A bit of training resources here, a couple of blogs that I think are pretty cool and you're definitely worth checking out. And without any further ado, I'm going to hand it over to Ben. So Ben joins us from Codify. He's been working with Microsoft Technologies since 2004, so it's a long time. So he's a director at Codify. Take it away, Ben.
Thanks,
and we're going to be
Damien.
talking about 8 new ways to optimize your company's Azure spend.
That's the plan, at least. Anyway, look, let me share my slides, and there is that. How does that look for everyone? A lot of orange, I hope.
That's very orange.
You can see it.
Yeah. So I'm just going to switch to. Hopefully, you've kept the screen while I've gone to presenter view.
Looks good.
Alrighty. Well, look, yeah, thanks, Damien. Thanks, Daniel. My name is Ben Parker. I'm a director at Codify, and 2004, 2002. You know, it's a life of IT for me. I've been an IT hobbyist my entire life. I think my first computer was an Apple IIe, and then sort of moved on to 386s and 486s, and you know, I remember pulling one apart. I don't know which one it was. I'm sure my mum and dad would be able to tell you. I remember pulling one apart on the kitchen table one day because I wanted to see what was inside of it, and there was death threats lay at my feet in terms of that better work when you turn it back on. And I didn't much understand what the fuss was about, but it certainly did power back on, and I'm here to tell the tale. I've wasted plenty of money on drones and Raspberry Pis, and done all types of projects in that space, more for myself and in my spare time. And yeah, I'll confess to having one or more, or used to have one or more 3D printers as well. So today, the reason for the conversation and what I'm here to present is, I guess, some of the new optimizations that we've been working with our customers on in Azure, and we call them new ways because a lot of these have actually been enabled through the release of products. So much like Damien presented at the beginning there, you know, with the changes that occur in the platform, there's normally new ways to either improve your service or in some cases also save yourself some money. So a lot of these, I think, these have all been relevant for a lot of our customers. And if I go back and think about a presentation that some of our team did to this same very user group pre-COVID, which was done by Josh and Alex from our side, and they gave an insight into what life in cloud ops looked like. We've really taken that, I guess, to the next level and sort of, you know, looked at back then what was our first Azure optimization guide, and you know, in retrospect, was probably quite basic and focused largely on reservations, hybrid use benefit, although that features again. Stopping and starting VMs, you know, they're the things that you should be doing and should have a good handle on. But we've looked at, well, what do we now need to do as that landscape changes? I think internally we joke around that the Azure platform very much is changing, not only week to week, month to month, but almost every time there's an Ignite or a build conference, there's, you know, a book of news that lands, and that's got hundreds of updates across the entire ecosystem. You know, apps and infrastructure, data and AI, IoT, the whole lot. So this list of these 8 things we'll cover off today has really been based off of the work that our service desks do day in, day out for our customers, and probably they're the biggest wins that we've had in that time frame. I guess it comes off the back of a recent case study that we did with Michael Hill. We've worked with those guys across a plan, migrate, run journey. And I think I'm very proud of this case study because it talks about the avoidance of cost. I think, you know, the only way to sort of say that and how we talk internally, at least, is, you know, the avoidance of cost is only really possible to understand when you look retrospectively. You know, you have to proactively manage these environments, and then you retrospectively get to look back at the influence or the avoidance of cost that we've achieved. For you yourselves today, hopefully there might be a saving that you can take out of your current bill today. But some of those kind words there from Matt Keys, who's the CIO at Michael Hill. I touched on the word run there, and I think just as an introduction to who Codify is and what we do, we are about this cloud journey that is plan, migrate, and run. And we'll find ourselves working with customers in everything from a business case to a migration. And run is that managed service or the cloud solution provider service that we have. And we've got a bunch of customers across government, retail, mining, not-for-profit that rely on our team sort of to govern their environments and to squeeze almost every last dollar out of it so they're getting the best bang for buck. We do often find ourselves talking to new customers, and there's a QR code there that sort of links to a blog post that you might find interesting. But we often find ourselves working with new customers or helping customers overcome that bill shock. And we have a couple of simple benchmarks that we rely on at Codify. The average consumption per virtual machine is a good one when someone might ask you at a barbecue, hey, I've got 50 servers, what's the ballpark to run that in Azure? The savings that are probably sort of relevant if you sort of consider a lift and shift approach to an application and based assessment with 6 Rs, they're the ones that we sort of trot out from time to time, and many of you on the call today might have already heard some of those. But what's relevant for the conversation today is what we see as, I guess, the average consumption across our customers. So if you think back about, we've got a good mix of them, and this is just a representation across all of them. There's undoubtedly spikes in particular customer sets, whether they're retail or manufacturing, which might have a heavy data warehouse footprint that might change the compute size ever so slightly and things like that. But this is a view of what we see a customer's total bill breaking down into. So we sort of classify it at a very high level to allow us to sort of come up with these, rough benchmarks for consumption. But compute, which would consist of all infrastructure and platform as a service offerings and licenses, we see generally in most of our customers, that's about 50% of the cost. There's about another 25 that sort of spans across storage, so disks or on VMs or blob storage or file shares. And then the remainder of that 25% is sort of shared across security and management, backup and DR, and networking. And when we get introduced to a customer, if they feel that they're out of control with their cloud spend or something like that, we use this as a bit of a benchmark to understand where there might be more conversation required, and that can then generally lead on to those optimizations. We worked with one such company. They were a consumer staples industry sort of focused customer, and they had a wildly different storage percentage over their total bill. That happened to be a result of the way that they did the initial migration into Azure, and they were using some NetApp replication solutions. Not that I have a problem with any of those services or anything, but they hadn't gone back and cleaned up the state of that environment. That sort of led them to quite a disproportionate cost around the storage element. So if you're here today and you're sort of a bit worried or a bit concerned about where your Azure spend's at, I'd encourage you to maybe benchmark yourself against some of those figures and see where you land. And if you've got any feedback about that, I'd love to hear it, because I appreciate that we don't have every customer in Brisbane or Queensland or Australia. And we'd always like to learn from what we go at it with opinions and talk about, and whether there's any options to improve on it. But into the main show to start off with. So we've got 8 of these to cover off tonight, and I thought I would try at least and see if we can make it a bit more interactive. And I've got some icons down the bottom that align to the team's reactions. So feel free to participate and share where you're at or where you think each of these land for you. But as a first point, I might start off unrelated to this topic, it might seem, but I'll come back to that in a second, is how long have you or your company been using Azure. So if we go from the left with a thumbs up all the way to the right with a hand clap, 1, 2, 3, or 4 years, might get people to punch in some of those right now for us. I'll also use these breaks here as well for an opportunity to answer any questions about the last tip that I presented. So if you do want to come off mute and ask, there'll be a opportunity to do that, as well as, you know, if you don't want to do that and you just want to put it in the chat window, I'm sure Damien or Daniel will give us that read out too, and I can try and address those as we go through. So whilst it might seem unrelated to this, generally what we see is the longer that you've been in the cloud, the bigger the problem is. And so when you start building out Azure virtual machines or app services or anything for that matter, you find that, you know, creating one thing from the marketplace generally results in, you know, a bunch of resources being deployed into a resource group. The virtual machine is a classic example. You know, if you're building one and then you go and delete it, you'll notice that left behind are disks, network adapters, public IP addresses. Similarly, for any app services that you might have, if you start deploying those the first time you do one, you're going to have to create an app service plan. But when you delete that app service plan likely exists afterwards, and you're still obviously paying for that, even though you're not utilizing that in your current environment. So looking for these resources that are largely disassociated or not connected to anything can be a massive cost saving. It's tip number one for that reason, because, you know, generally speaking, you know, when we're onboarding a customer through that service desk team, or when we, you know, discover the cost or bill shock, you know, there can be quite a number of resources that you're paying for that, you know, you're not even aware that you have, or you know, they're just left orphaned in the Azure plane. The Azure portal makes this quite simple to go and find, and you know, in more often than not, you can look for the associated to field. So when you're lurking around in the Azure portal and you want to, you know, maybe search for public IP addresses, you can edit the columns that are available to you and add the associated to field. That'll then show up not only a list of all of your public IPs in the resource group and location that they're in, but it'll show you what they're associated with as well. That trick works across most things. However, I would add caution with one of them, which is when you start looking at managed disks. So you cannot rely on the associated to field when you start looking at managed disks. Actually, I don't think it even exists as an option. But what you can do is add the disk state. Now, managed disks are quite easy to leave behind after deleting a virtual machine, and they're also quite costly. You know, a public IP address might only be a couple of months, but if you've got a couple of terabyte hard drive, that can cost you a couple of $100 a month, and you really want to make sure that you can, one, clean these up, and two, you don't delete something that's actually in use. So in this example here, there's a couple of options. So the first one is obviously reserved. That's the equivalent to, you know, it's associated and in use. We've got then unattached. That's obviously safe to delete. But these things that we see like active SAS as well, you know, they might be things that are associated not necessarily to a virtual machine. A good example of that is if you're using Azure Site Recovery and you're replicating virtual machines from on-prem via Hyper-V or VMware, whatever your poison is, or even if you're doing cross-site replication, cross-region replication in Azure, you know, you'll start to see that these virtual machines show up with an active SAS connection. So, you know, they're not safe to delete and they're actually locked behind the scenes. Before we move on to the next section, I'll pause for any questions. But while you come off mute to say that, hybrid use benefit. Now, I did say that this was basic, but I'm going to add a correction here, which is you've got to do it correctly. So the reactions, I guess, that I'm looking for here is thumbs up if you're all over Hub and maybe feel that you should present this topic. Maybe for a love heart, we have so many licenses, it's not funny, and this will never be a problem for us. You'll be the envy of many customers, at least of ours. A smiley face, you'd rather maybe not know what the current state is, and smile and nod seems to be appropriate. And the hand clap is, I'm pretty sure someone else looks after this for me. Alrighty. So I promised the basics to start off with. Well, I didn't promise them, but I'll give them to you. I'm going to preface everything that I say with it, which is always check with your licensing specialist, as your scenario is likely different to everyone else's, whether that means you're on a enterprise agreement or open agreement or whatever it is. But put simply, hybrid use benefit is a software assurance benefit that you can use across either Windows or SQL in Azure. I guess the golden candidate or the goose that lays the golden egg is having data center licensing for Windows on premises and continuing to use that while you then reuse that benefit in Azure and don't pay for virtual machine or pay for the Windows component of Windows virtual machines in Azure. So put simply, I guess it converts, if you're looking in the Azure price calculator, it converts a Windows virtual machine SKU into either still running Windows, but into a Linux-based pricing. It's always based off the number of cores of the virtual machine. And for every 2 processor licenses that you have of data center or standard, that equals 16 core licenses that you can then use in Azure. You have to, at a minimum, before you can even start, have 16 cores. So the two processor license of Windows Data Center on-prem. But every Azure virtual machine, you must use them in allotments of 8 vCores in Azure. So if you've got a virtual machine with 2 Azure virtual machine, that is, if you've got an Azure virtual machine with 2 cores in it, you're actually using 8 vCores out of your hybrid use benefit. The way we start with this planning is to generally sort of work out the total quantity of licenses that you might have in that data center space, and then divide that number by 8. And you have to dismiss any fractions that might exist in that equation, but if you've got, that should give you an indication to how many virtual machines you can possibly apply that to. The SQL scenario is slightly different, but it's applicable to the Azure PaaS instance and is something that's applicable only to the Enterprise Edition. So there's a difference there between the general purpose and the business critical SKUs, but they apply in a different way, and they apply to the Azure SQL offerings in terms of the same SKU. So whether they are GP or hyperscale, if anyone's using that, or even business critical. So the mistake that we see often, and I'll probably address the first point there as well, is not understanding or not allocating them appropriately in the group of 8. So as a first point of call, you should start by looking at if you've got 20 virtual machines that you can possibly assign to based on the hybrid use credits that you've got, you should first off order those by virtual machines that are in 8 CPUs or more. So that way you're taking full benefit for the Azure hybrid use benefit that you're applying. And if you've got if you've got a virtual machine with 16 cores, that would consume 2 of those. If you've got a virtual machine with 8 cores, that's going to consume 1 of those credits. From there, you then can filter down into your 4-core, 2-core, 1-core, and you should have apply them in that order. So you're getting the best bang for buck at every scenario. The other thing to do is to consider the SKU size as well. So, not all Azure SKUs of virtual machine are the same, and the savings differ between each one. A classic example of what we've seen in the past where where customers have made these applications is they've started applying them to some of the specialized workloads. The B series, if you weren't aware, is a burstable CPU SKU, and on average for each 2 cores, the hybrid use value is only worth $8 approximately, which comes in at about a 13% saving from the actual virtual machine cost. That's obviously because there's limitations and credits for bursting that are on those virtual machines. And if you compare that with what's screenshotted here, which is Azure Virtual Machine and F2, which is a good old stable workhorse, the hybrid use benefit saving from that is $92 per month for that one Azure VM. That's an approximate 45% saving. So not only should we apply these in groups of higher number of CPUs first, but we should also make sure that the SKUs that we're applying them to best fit and we get the best value out of them. So in a recent example, we worked with a customer. They had 67 licenses over assignment, so they were overcommitted, and we corrected that back to a compliance state by not only removing DevTest and B series virtual machines along the way, but we also managed to achieve a saving by applying them through this manner. So even if you're doing hybrid use benefit today, and even if you're that expert on licensing, and I definitely don't profess to be, but making sure they're applied in that order can possibly net some pretty big savings as well, which is why it's tip number 2 for us on this list. I'll pause again for any other questions, but this one, so the Teams reaction emojis I'll use here. First up, thumbs up if you're premium SSD all the way across all environments for all reasons. Maybe a love heart if you've got a mixed approach, whether that be from DevTest or even workloads in type. Maybe a smile face if you are still using standard hard drives across the environment, and maybe an applause if you're not using any Azure virtual machines whatsoever. Alrighty. So, look, I mean, the narrative is quite simple in that, once upon a time, premium SSDs were kind of the only way to go. Not only did you get a single instance SLA from Azure for those virtual machines, but generally, standard hard drives, at least in my experience, don't have the best performance, and they're certainly not reliable in the performance that they give. And I think Microsoft recognizes that even on their docs.microsoft website as well these days. A while ago, quite some time ago, standard SSDs were introduced, and we saw customers pivot to those, particularly for light duty virtual machines where there wasn't huge disk requirements or things like that, or they didn't need to have an SLA because there might be multiple of them in an availability set or something like that. But what was recently announced, and what made us pause for thought and maybe push it a little bit more aggressively, was a recent announcement around bursting for Azure Virtual Machine or Azure Virtual Disks. So there's now, similar to the B series virtual machine on standard as well as premium SSDs, there's now bursting options for increased performance on ad hoc workloads. So if you've got a web server that is maybe accepting files on upload or bulk transactions or something like that, or doing some offline processing where you do need a bit of disk performance and you're a bit worried about standard SSDs in the past, with this new bursting capability, it's probably worth revisiting that. Simply switching from a premium to a standard of the same size is a saving of approximately 33%. That doesn't always scale linearly across the different sizes, but it's a good rule of thumb to use as you're doing those workloads. And if you imagine back to that initial graph, when we look at storage costs and Azure managed disks being a large proportion of that, consuming somewhere around about 25% of your average bill. A 33% saving of that is pretty remarkable, which is why it is here up so high in our tip list. Some proof in the pudding there, and I'll just by a quick introduction, this is our cost management portal. It's we use this with our customers to help them understand their bills and things like that. Those aren't real resource group names, and the resource names have been hidden to protect those who've benefited from this, as opposed to protecting the guilty. But what is important to see here is this column here, which I want to showcase. So, we're looking at a month-on-month comparison, 29 days between March and April back in 2021. And this is the cost difference that we've been able to achieve just by switching to SSDs in that space, the standard SSDs, and obviously the percentage that results in. Now, the big win, and this is not all necessarily just virtual machines that are attached to virtual machines, but when you think about if you're using Azure Site Recovery for replication, there is no compute component to that. So switching from a premium SSD to a standard SSD can save you significant numbers as well. So, worth investigating if you've got a bunch of virtual machines and you haven't looked at this stuff in the past. It's worth a revisit. Pause there again for any questions, and maybe for these reactions. So again, using Teams reactions, the thumbs up. Let's use that if you're using Azure SQL today. Appreciate that not everyone is using that, but the SQL as a service option. The love heart if you are already well versed at optimizing, even maybe you've got some reservations on your Azure virtual machine, Azure databases in the cloud. A smiley face if you're maybe still using SQL on Azure VMs. And a cheer or a clap if you'd rather be talking about Cosmos DB. Alrighty. So this really came up, I guess, with a customer that was heavily invested in IAC for their environments, and they were using, they were building out of Azure DevOps pipeline, the server and the database that sort of existed with that, and they were doing that for every environment and every demo and every trial they were sort of spinning up. And sure, they had they had the configuration and the environment sort of at a maturity where they were destroying the environments once they were completed with, but there was still an inordinate saving to be achieved by switching to elastic pools. So the elastic pool context is, you can have multiple Azure SQL databases running off the one shared compute element. There are some constraints when you do consolidate them, which might not make it a best practice for everyone. But there, for example, you can't have more than one DB use 75% of the resources. You also have to factor in that all those databases are using the sizing of that and contending with or sharing all the IOPS that might exist on the disk infrastructure behind that. It's really it's great for DevTest workloads where you don't necessarily have constant demand across all environments at one point in time. But obviously do use a bit of caution if you're looking at this in production, because you will have, you don't want to introduce contention into the mix. There is a significant operational benefit if you do look to production for these workloads, in that on the Azure SQL server itself, that's where you configure not only the sizing but all of the backups and long-term retention, point-in-time retention for your databases as well. So you sort of have a single console where you can do all that work and ensure that your workloads are protected going forward. This is a screenshot. Again, maybe in this case, the guilty have been protected but we've got here, just the sheer number of databases and that were in the environment and that were being spun up, as I said, out of IAC. But the cost of these, Gen 5 V, 2 V core general purpose virtual machines quickly grew, and that's where we were able to achieve that saving. Despite this long list of resources here, take a second to appreciate the size of what's beneath that in terms of scrolling down and just looking at the what remaining Azure SQL databases were there, which was how we're able to achieve such a saving. But that was all non-production, by the way, from memory too. That was a specific subscription, so looking at one subscription there. Right, so I'll pause again for any questions, and maybe here, if we talk about this is actually one of my favourite topics to talk about, and we've done this a couple of times for a couple of different customers, but it's moving away from app service environments to looking at the private link for app services. So thumbs up if you are using app service environments today. Love hard if you have everything internally facing, all those websites at least, on Azure virtual machines. Maybe a smiley face if you don't think I can convince you that I can take away your ASE. And if there's those on the call that are using spas or single page web apps, you can applaud, because you can probably just use static websites out of an Azure storage account. So bold statement there that ASEs are dead and long live app services. So yeah, ASEs were traditionally the only way to get infrastructure that was platform as a service website hosting hosted internally on an internal virtual network. Or at least for inbound connections, we've often had the ability to do inbound connections from an app service through VNet integration. But if you wanted your end users to access a platform as a service, an Azure app service, you would need to use an ASE to connect to be on a private IP address space, which you could then have your users use. If you've got a lot of internal facing apps that don't have rigorous authentication protocols, or maybe they're a bit too you maybe appreciate some of the technical debt that's in them and you don't want to have them public facing where the internet can get to them. They were a bit of a staple in terms of hosting. I'd say they were, as someone who's deployed a few of them in my time, they were slow to build, they were very slow to scale, and the deployment to them wasn't necessarily straightforward as well. If you were looking to do them, with an Azure DevOps pipeline, you kind of found yourself having to use a deployment agent internal on your network to then connect to that public IP, or at least to the SCM interface to configure the app service and deploy code to it. Aside from that, for a lot of customers that we spoke to, getting the first one was somewhat cost prohibitive because of the stamp fees. So, there was as with everything in public cloud, regardless of the vendor, when you talk about dedicated infrastructure and you talk about isolation and things like that, it's generally a straight line to the bank account, and it's going to cost you some money. In ASEs, they were stamp fees. So, depending on the size and depending on how many of them you had, you're at least up for a couple $1,000 just to start. And sure, once you've got a number of them up there, you can maybe look at amortizing that across the entire set of apps. But for the first one, it can be quite expensive to get up and running. So I guess at that point, we saw an announcement quite some time ago now, but it's been growing in momentum and growing across all of the Azure platform as service offerings. I was instead of actually saying which ones it supports these days, I think it's maybe easier to say which ones doesn't it support, or even knowing where that list is might be the easiest piece. But Private Link allows you to initiate an inbound connection to an app service as well as a storage account, whether that be blob or file or a number of other Azure services as well. So with that, we move away from the dedicated infrastructure that an ASE had, but we retain, I guess, the network boundary or that perimeter that you might have been leveraged, that you might see as more of a benefit than the dedicated infrastructure piece. We have app services that we know and love and we can deploy to, and we can wrap firewalls around in terms of which VNet's allowed to get to it and things like that. And we can even put NSGs on top of them so that when it's in our virtual network, we can still achieve some type of micro-segmentation by only allowing certain networks to access that private link. As a result, we've been able to save some of our customers quite a hefty amount of money. And a couple of examples here, but of where we've been able to make those savings by switching over to those app services, switching from ASEs over to app services. Now, unlike a lot of the other things I've presented today, making the change isn't as simple as a click. And a private link itself might require its own Azure user group session, but the brief sort of 101 over the service itself is it's got a requirement on infrastructure, and you really need to consider it's a rebuild of that infrastructure, and then redeployment of your existing sites to those app services. So if you've already got a mature DevOps process, that'll be easier for you. Unfortunately, if you don't, that's not necessarily going to be as easy, and you might find yourself taking the time to invest in building out pipelines to deploy that code into these app services. At the same time, you can sort of get a bit of a 2-for-1 deal, and that if you were to make the move from an ASE, if that's what you've got today, you can make a move to the new V3 app service plans, which give you for approximately the same money, or within reason, you get more CPU and more memory, which arguably means that you can probably run more websites on them, reducing the number of plans that you have in your environment. To talk briefly about this infrastructure, I'll leverage this diagram, but when we talk about private link, when you deploy private link, you're thinking about bringing that storage account, or this app service in this case, you're talking about giving that a local IP address on your network. And in order to do that, you don't want to be connecting over just an IP or using host files on PCs to get that connectivity. Might be fine to test that you've got everything in place and your NSG rules and your route tables and things are fine, but it's not something that you can go to production with very soon. So the infrastructure that we need is really DNS related. So we need to have our on-premise DNS servers, which our clients are going to connect to. We need to have this server resolved to the private Azure DNS zone. Now, when the client is going to make a request, it's going to make a request to the local server. We need to tell this local DNS server, which is likely some AD domain controller in the mix, we need to tell that to, first off, forward that request to an Azure-based DNS server. So in Windows DNS land, that's called a conditional forwarder, and we're going to say for the DNS zone that is websites.azure.net, we're going to delegate that, or we're going to set a conditional forwarder to forward to our DNS server in the cloud. Now, if that DNS server in the cloud happens to be a domain controller, you do want to make sure that when you create this zone that you're not using an Active Directory integrated conditional forwarder, because that would then do the same solution here, and you'll end up just in a round robin of DNS recursion, it looking at itself constantly forever, and it won't then leverage the private zone's information. So we then have to specify a different DNS server. So this virtual machine that's in your network, and again, then we'll assume it's a domain controller, we need to add, again, a conditional forwarder, but we need to forward it to Azure's DNS server. So that's a non-routable IP that's only accessible from Azure VNet at 169.254.something.something. And we want to make sure that this server passes those same requests to the Azure DNS server itself, which will then in turn give us a response from our private DNS zone in the cloud, and which will in that case resolve our app service as a private IP address, and the user, that'll all then flow back, and a user can access that IP directly, the IP directly over ExpressRoute or a VPN gateway or whatever infrastructure you might have on-prem. The scenario for maybe an external user, if you are using an ASE and you have that internal for maybe integration reasons, or you're hosting public infrastructure off that for whatever reason, you can still achieve the same scenario. External users are going to hit maybe your WAF or app gateway or something on your edge, maybe a network, a virtual firewall or of some capacity. This application gateway is going to use the Azure DNS and use the private DNS zone to resolve to this IP address as well. That's all really the infrastructure that's required, and in many scenarios you can rinse and repeat this private DNS zone and infrastructure for routing requests around for all of the private link infrastructure pieces as well as you go forward. Private link exists, I guess, as a network adapter and a service inside your VNets, and so you should also consider deploying them into like a shared subnet, and then you can apply those NSG rules around them appropriately. I believe it's still the case, and I was trying to find this before the presentation, but I also believe, and this might be changing soon, that you still can't use route tables to direct where that traffic goes. So if you've got sort of complex routing requirements, sending things to or having disconnected spokes in your environment, or forwarding traffic to virtual appliances, you just need to be cautious about that deployment. I know in some examples, probably quite some time ago, you weren't allowed to put a route table on that subnet where the private link was working. Well, I think you could do it. I just think private link ignored it. But I think that's work in progress, if not already resolved. Maybe someone else knows that answer, and they can come off mic and tell us all. So the next one, while you're thinking about that, so some Teams reactions here, and I guess I've sort of moved two items into one here, but reviewing your backups, I think we all know and we all have them probably configured in our environment, but optimizing them and sort of right sizing your backup footprint is can net some pretty big savings. So in terms of the reactions here, thumbs up if you're using Azure Backup today, maybe a love heart, depending on your point of view, if you are backing up your Azure environment to some on-prem solution software or the like. A smiley laughing face if you just back up everything and you have a requirement to back it up forever and never delete it. And maybe an applause again if backup isn't your job and someone else looks after that for you. Alrighty, so review backups. So whenever having a conversation about backups, I guess there's many elements to this, but the first two generally should be RPO and RTO. So RPO is the recovery point objective. So if we look at this sort of side of the graphic, the lightning bolt represents a disaster. It could be rising floodwater, or it could be a COVID icon, but take your pick your poison for that. The recovery point is the time in which the maximum time in which we need to go back in order to recover a stable system. So it could be another way you could think about that is I'm running a daily backup. Therefore, if I'm using Azure Backup, I've got a 24-hour RPO. and I could retain that for X number of years, depending on your internal policies. The RTO is the time it might take you to recover back to that previous recovery point. So again, if we're using Azure Backup, we might have a recovery window of up to 8 hours. I mean, that's going to be a sliding scale depending on how big the virtual machines are and how many you're going to request. I'm sure there's an SLA somewhere from Microsoft around that specifically. But if you're storing Azure virtual machines with Azure Backup, I'm pretty sure you're going to get them done within 8 hours. The inverse of that, if you're using or leveraging Azure Site Recovery, you've got far more recovery point objectives, and it could be an hour, it could be 15 minutes. In some cases, if you need app consistent ones, it might be 2 hours. But the retention period is obviously not going to be the same, and we're going to measure that likely in hours and not years. I think there was a recent announcement where we could probably safely talk about days. I think there was an announcement the other week actually to extend that to 30 days. But the recovery time is obviously going to be a lot faster because that's essentially a warm recovery point in that it's replicated into a disaster recovery environment and it's already there, and you're orchestrating it through the site recovery console itself. But if we think about the defaults and we think about what we find customers using, there's maybe more so for the Azure Backup piece, but we're going to have these sort of snapshots or these recovery points that exist that we can optimize. So the Azure Backup default for daily retention is 30 days. You can, I think the first trick that we have when we're working with any new customer and looking at backup costs in terms of that percentage that I sort of outlined at the beginning, it's about reduction of that. So in a DevTest environment, do you really need to have 30 days? In a production environment, can you bring that back down as well? If it's a web server that arguably has no persistent or data stored on it, maybe that can be reduced to 7 days, and then you can move into weekly backup rotations as well. Every chance you can to optimize that is going to reduce the number of snapshot or the number of recovery points, which will in turn reduce the storage under the covers as well. That same principle applies for weekly, monthly, and yearly recovery points as well. There are some specialist cases that are worth noting as well. So if a bit of a nod to the first tip, which was deleting resources that are unassociated. If you delete an Azure virtual machine and you're using Azure Backup, that backup the final backup that was stored for that virtual machine will go through its grandfathering process, and you'll reduce the number of snapshots that are there. But the final snapshot or the final recovery point is probably the appropriate way to say it, will be retained, and you actually have to go and manually delete that. So if you find yourself in an environment where you're building virtual machines and you're just automatically provisioning the backup over those, and maybe it's just 30 days and you need to reduce that too, it could be worthwhile looking back in the Azure Backup Vault itself and looking for virtual machines that no longer exist that you still have that data in retention for. That can be a significant cost, not only because it is the storage that you're paying for in that case, but you're also paying the Azure Backup instance fee. So when we look at the consumption model behind Azure Backup, don't forget there's obviously a storage, gigabytes stored for however long they are, but there is also a cost or an agent or an entitlement fee, depending on your point of view, that you pay per virtual machine, and it's a tiered scale where you pay half price for something like anything below 50 gig, and then full price for every time you use more than 500 gig. I think don't quote me on that, but they're the ones that come off to my head that you would be paying for on that virtual machine still, even though you may no longer have that, and you're likely backing up that same data through another mechanism as well. If for whatever reason, and maybe you threw up the love heart, I think it was, which was you keep everything and you never ever delete it. There was a recent announcement in that there is now support for storage tiers of your Azure Backup storage as well. So it's a very specific set of use cases, but it is primarily targeted at long-term, monthly, yearly retention and moving that to archive storage. And I think we'll see shortly that archive storage can save you 90% if you go from hot, which is the default behind Azure Backup, to an archive tier storage version. Skew, for lack of better words. So worth exploring that. The next one, so everything that I've said up until now is absolutely true for Azure SQL backups as well. And you should look at your retention period for point in time and long-term recovery, as I sort of stated on the previous slide. Probably the other specialist case or the consideration there is really around point in time recovery, the duration that you have that, and the what you're actually using that database for. So we just think about the Azure SQL cost levers. So we pay for the compute element, so the number of virtual CPUs, the generation of them, business critical or general purpose as well. We pay for the storage, which is the amount of active data that we have attached to the database, so log and data, sort of in our traditional SQL thinking. But we also pay, there's a separate line item or a separate meter in Azure for backup storage, and that consists of point in time storage, whether that point in time storage is geo-replicated or whether it's just locally redundant in Azure. And if we think about point in time recovery as the ability to be able to recover back to any point in time, it means that we're, in essence, keeping data that we might in otherwise ETL processes or bulk operations be rewriting over. So if the database is used in that scenario where it's more of a data warehouse or some type of staging system and it's not an authority, I'd really encourage you to consider reducing the point in time recovery window to as least as possible. If you think about, you've got a data warehouse and you've got some tables and you've got a data factory job or maybe even an SSIS job or something like that that's pushing data to that table. If the first task of that is to truncate and then re-import or do a bulk operation to upload the data, you are likely or you could consider yourself just deleting data and then reloading the same data over the top of it. So reducing the point in time recovery window means that you're not just having this daily process where you're truncating tables and then putting data into it forever, perpetually for 30 days or whatever, 35 days the default is. So reducing that will save you some costs. But I mean, ultimately, long term, shifting to other mechanisms for doing that ETL or throwing ETL out altogether and looking at Synapse and some of the other cool platform technologies in that space might be advantageous as well. But from an infrastructure lens, you can certainly make that improvement and reduce the cost, particularly if it's not a source of truth system. So some significant savings in terms of percentage there that we're able to drum up, but it's obviously going to be based on what you're doing in each of those environments to save money. This is obviously looking at an Azure Backup Vault and deleting virtual machines and right-sizing the retention. The retention periods that we have in the environments we look after as well. All right, so I believe we're on to the last one now, and this is a bit of a nod to the backup one as well in terms of looking at the storage account tiers. So in terms of the team's reactions, maybe a thumbs up if I have all my data in Azure Blob already. A love heart if you are still using SMB file shares everywhere. A smiley face or the laughing emoji if you are you've built a data lake and you've got all this in hand, and maybe the applause if this is you're just happy to hear it's the last one and you've been waiting for your dinner, or maybe you've been eating it the entire time as well. So Obviously this is going to depend on how much Azure data that you've got within the environment, but whilst with unlimited capability, we have this habit of retaining data forever, whether you consider it digital landfill or a data lake. There's an opinion behind either of those use cases, but it is it's undisputed that we are generating more data and we are keeping that data longer because we're hoping to achieve insights out of it. Hot by itself is the default, and whilst it might be relevant for the immediate use of that data, once you've moved on to a different pain point or uploading different things, or maybe it's just become out of the organizational's current frame of mind, it is also expensive to host that long term. So the biggest saving that you can have, at least in a percentage case, is by switching that to archive, and you can save 90% of that. There are some trade-offs, and they're sort of listed there, where you've got hot, which is always available, always on, and it's available at speed. The other two tiers sort of step back from that statement ever so slightly. And just like private link can probably deserves its own user group section, maybe Azure Storage in general does as well. But for hot storage, it's always available, and it's always as fast as you can get it out of your network links or maybe the limits on a storage account. It's going to come down to you. The cool tier is, well, it's always available. You'll be able to get to it, but it's just going to be a little bit slower. So you're going to have a longer time frame to download or get access to that data directly in Azure or on premises. And archive, I guess the joke there is it'll be with you shortly, because it's there in some cases, and I've yet to really see it in anger. There can be a time delay in terms of actually accessing that data as Microsoft moves it into that archive state as well. As we go back, saving a lot of money, and appreciate that this involved probably deleting a bunch of storage as well, but switching that to archive tier for one customer that we had netted a pretty big saving as well. So lastly, last slide is, if you're interested in this type of information, our latest guide is available. There's a QR code in the bottom corner, and you can go and check out the detail behind a lot more of these tips. You can also reach out to us on the Contact Us page, or you can always just grab me on Teams. I'm pretty easy to get a hold of at ben@codify.com. But thank you all for listening to me talk through these tips, and hopefully you found something useful. And hand it over to any questions anyone might have.
So Peter's got a question there. Does the storage tier access cost make a difference?
Yes, it does. So yeah, if you start accessing those cool tiers and the archive tiers, I guess you're introducing more meters in terms of the cost element. So probably talked about the performance of it, but if you start accessing that data, there's a fee to access that as well. So when you think about the age of that data and who's using it and how often, you do definitely need to give that some careful consideration. I wouldn't move everything to archive by default, although I'm sure in some organizations that would probably work. You do need to put some consideration into it's out of the organization's current context of mind to use that or access that data long term.
Fantastic, Ben. That was a really good presentation. I definitely learned a lot. I hope other people did. Dan, do you want to say a few words?
Yeah, no, well done. That is really, really, that's really very helpful stuff. I mean, saving money is certainly motivation for any company or any organization. And there's some really good tips there. I know there's a few things I never thought of either.
Gary says, thank you. Maybe we can come off recording, and if anyone wants to ask any unrecorded questions.
Sounds good. I'll stop the recording now.